In this video, we will continue from the Crestron driver's JSON and PKG file video and load and test our driver. In our test setup, a DIN AP2 will be used as our device emulator, and our code is loaded to a CP4N. To begin with, we will see what it takes to integrate this driver with a simple Windows program. Taking advantage of the certified driver's display Ethernet version 1.16 module in our program, we have provided a multiple serial send with the driver location and device IP address, an analog initialize with the port number, and declared several signals of interest on the driver's display Ethernet version 1.16 module. These include the triggers to load the driver file path, and feedback for whether or not the driver is loaded. Under the information section, we should get any metadata that we had entered into our driver. Under Communications, we have feedback about the comms. Under Power, we have control of power on, power off, with feedback as to its state. And we have an input section with feedback. Our simple Windows code has been loaded to an available slot on the CP4N, and debugger is open. In File Manager, in order to load our .pkg file, we need to first locate the user folder in the processor. The PKG file will be loaded directly into the user directory. When testing new iterations of a driver, always restart your program after loading the PKG file if you already have loaded a previous driver. We can see based on the feedback of our program and debugger that currently no driver has been loaded. We will trigger the load driver signal named here as init load driver. Some of the feedback we receive involve the metadata from the unit, and some of the support's feedback based on the device support section of the JSON file. At the bottom of our debugger signals, we can see the status of those feedbacks here. Checking in console shows debug outputs that are useful in determining what's going on with our driver. Checking the status of our emulator shows that upon load, the TCP connection was made and the status is 2. From here, we will trigger some of the commands we have defined in our protocol. Power on. Checking the emulator, we see we have received the power on command and sent the appropriate response. Now, let's check what the driver saw. A display protocol sending to transport power on. A received message coming in from the device. From our response validation class, we see the incoming command has been compared to the JSON file and provided a command group of power. Checking our status, we see that power on feedback is, in fact, true. While the unit is turned on, we will attempt to set an input. Sending to transport input 1. Here we see the details of the input number. We have the response saying we have successfully set the input and the command group has been successfully identified as input. Over on our status, we see that the input is showing as selected. Our emulator reports the same. Let's try input 2. Here we see our feedback and we see our status has updated. Once again, turning the system off. We can see that the power on feedback signal has gone low, indicating that the unit has turned off. All outgoing messages and incoming responses from our emulator have been processed by our driver. In our next video, we will look at integrating this driver into a C# for Crestron program. Thanks for watching.